Hello, everyone. Thank you for joining us for another Artex Academy webinar. Today, we'll be talking about sustainable cow cooling. I just want to start off with saying that we have a question and answer section at the bottom of your screen. You should be able to click the button. You can ask questions throughout the presentation. We'll be answering them at the end. There's also a chat feature if you want to send us a message. Again, we'll answer it at the end of the presentation. We will have one poll during the presentation and then another at the end where we just ask for some feedback on the presentation and get your feedback on how we're doing. So I'd like to start off with introducing Sue Hagenson. She is our Senior Dairy Specialist. Sue, you want to take it away?
Sure. Thank you, Karen. Welcome, everybody. Today's topic is going to be around sustainable cow cooling. I just want to quickly introduce myself to the audience in case you're not familiar with who I am. So I'm originally from New Zealand, very much dairy farming, agricultural background, went to Massey University. Then I worked for livestock improvement and the Farmwise group within the company for a long period of time before taking my family and moving them to Uruguay and also to China. I now reside in Canada and work for Artex Barn Solutions. My role is quite a cool one. There's a lot of variety. I get to go into a lot of regions where I'll call it new dairy farming industries. So it gives me an opportunity to do a lot of problem solving, a lot of strategies, some training. And the cool thing is when I go back, I actually get to see some really amazing results, which happen as a result of it. One of the things that really attracted me to working for the company is that, as cheesy as it may sound, it's all about the cow. So we're very much focused in the cow's needs over anybody or anything else, obviously taking into consideration what the customer needs and the customer's budget. So just to kind of kick off, although, like I said, I've been involved in the dairy industry pretty much from the get-go, in the last 9 years, I've actually learned a heck of a lot about cows. Sounds really strange. New Zealand, very much pastoral-based dairy farming. So the cows, they live 24/7 outside, and on some particular days, based on the farm, they actually don't get any shade. Our cows, they go to be milked, they're packed into a holding yard, and most of the time those holding yards don't have a roof over it, so no shade. Sounds really, really crazy, but you don't know what you don't know. Our dairy farm was a little bit more progressive. We had soakers, or actually sprinklers, running around the outside of the yard. Again, probably not as good as it should be, but we thought it was better than nothing. You would typically see at some point after Christmas, milk production would drop, and we would attribute that to the pasture quality dropping, because we're now in through the heat of summer. Our cows are more pregnant, so days in milk will also deemed to be creating that drop. As I want to remind you all, in New Zealand, most of it is seasonal supply dairy farming. So it means that the herd is dried off by the end of May. And then based on where you are in the country, you start calving again in July, and that cycle repeats. When I moved to China, I was managing a 3,000 cow farm, and they were housed. So this is where I got to learn, as we called it, confinement farming. I was fortunate enough that I was working for a company that really strived to have the best conditions for the cows. So our ventilation and our cooling strategy was very much based on fast moving air over the cows and applying water to assist with their cooling. So I learned a lot of stuff. We learned it also a little bit by trial and error. We learned that when you ventilate and cool the cows properly, they are more healthy through that summer period when it's hot. They do actually make more milk. They are actually easier to get in calf. Those calves really are a heck of a lot easier to rear. And we saw more of our replacements coming through, getting in calf easier, calving as 2-year-olds and staying in the herd, and that positive cycle repeated. Now, the reason why I say we learned that by default is that the dairy farm that I had, which was a nice, bright, shiny new one, had ventilation and cooling built into the dry cow barn. However, we thought, oh, we don't need that. So in the first year, we actually didn't turn it on. And we did have a whole lot of challenges with our cows and with our calves. And when we turned it on in the following year, we saw a massive change in herd performance. So when I was putting this whole presentation together, I was looking at, we have this delicate balance act, and I was of the opinion that this delicate balancing act was all around the cow comfort, the cow performance, and that investment per cow. However, as I kind of left this beautiful picture on this page and went through and put the nuts and bolts in this, I realized that this, in fact, was not the balancing act, that the balancing act was between the mindset and the investment. And the reason why I say that is because dairy farming and a majority of the agricultural based businesses is very much based on historically what has been done by my father, by their father or their family, and so on. So we're building up this, this memory bank of passed on through the generations of this is done like this just because. If I grew up in an urban environment and I chose a profession, I wouldn't necessarily have all that historical hang up or baggage that I would be bringing to the table. I would be learning through a lot of my own experiences. So I hear a lot around, well, it always happens this time of the year, or, well, this is what we have always done before, or, the uncertainty of, if I spend this money on the ventilation and the cooling, what outcomes am I actually going to expect to find, or what can you guarantee me? Now, it's interesting because the majority of the people know that their herd does experience heat stress. However, they can't seem to, I guess, take that plunge in terms of investment. So investing in that right solution, which isn't necessarily going to be the lowest capital cost, but it's probably going to be the lower operational cost. So the other really cool thing about dairy farming is that you can have two very identical dairy farms. They could be right next to one another. The facilities are identical. However, they get very different results. So, sustainable dairy farming. When we hear the word sustainability in relation to dairy farming, what comes to mind? Do we go, roll our eyes because we're thinking of, the environmental people who go to the very extreme about, bad dairying? Or are we thinking more along the lines of sustainable dairying? Am I still going to be here in 2 years, 5 years, 10 years? Will my family still have this dairy farm? Will it still be sustainable? And so that's how I look at it. Is what I'm doing today still going to be okay tomorrow? Am I still going to be here? Am I still going to have comfortable cows, cool cows, healthy cows? Are they going to get in calf the same time every year? Are my cows meeting their full genetic potential? Am I actually being environmentally friendly? So by that, I mean, am I being a really good custodian of the natural resources that I know are not unlimited? And most importantly, am I actually profitable today? And am I still going to be profitable tomorrow? So today we are going to look at sustainable dairy farming, and we are going to be focusing on cow welfare. And by that, I am going to look at heat stress, and I'm going to look at it from the impact of the different ventilation and cooling mindsets. And why I want to do this is because, I've had this massive opportunity up until, the last 4 months, where I've got to travel around the world and I've got to see so many different things and so many different misalignments and so many different reasons for and for not. Most people know that heat stress does have an impact on cows. And interestingly enough, there are still levels of disconnect. You know, some guys, they really understand the true value of what's needed to do the job properly. Some farmers believe that they can't afford it. And some of these farmers really just don't understand. Maybe they think it's not necessary. Maybe they think it's just not hot enough. I mean, I have a number of examples, but one that I find, you know, quite interesting is working with a dairy farmer who's investing in building a new farm. And we all know that it's a huge investment when we take the plunge to build a new one from the beginning. This particular person had decided that he was going to, you know, I guess scale it up. So start with a couple of barns, see how it goes, then grow, grow, grow. So his farm was located in, or is located in, a very hot and humid climate. And so in that region, ventilation and cooling is not negotiable. However, he did not want to invest in the ventilation and the cooling until he had that farm operating for the first 12 months, because he wanted to see whether or not his dairy farm could be successful or not. He saw this as an absolute cost versus, if I invest in this, this is what I'm going to get back from my cows. So although he knew that the climate that he was in needed to have ventilation, because they were slightly higher up in altitude, didn't need to have ventilation. So thought that they would be okay if they didn't do anything, that they wouldn't suffer from heat stress. So as I've gone around, I've gone, okay, well, I have 3 categories of business or dairy businesses. So I'm going to go through those 3 standards. So the first one is the gold one, or the good. So what does good look like? So from what I've seen, these producers, they understand the value of what is needed to do the job properly. They are 100% invested. So they're 100% invested not only in ventilation and cooling, but getting obviously cow flow and all other aspects of building it once and building it right. They understand that good ventilation and cooling is actually a capital investment, and there will be a return on investment. That they need to do this to make sure that their business is going to be sustainable. They have spent a lot of time investing in getting the right advice. They've also done their own investigating, and they are absolutely committed to putting this solution into place 100%. So they're not putting 80% of the solution in, they're going to put the whole thing in, and they understand that they have to manage it. You just can't put your fans in, put your cooling in, and kind of walk away and just let it run. It actually has to be managed. So these guys have identified for their location, their climate, their farm type, their barns type, what are going to be the critical air speeds that they need. And they understand that inside their barn, that they have all these microclimates, and that air is not evenly distributed throughout the whole barn, right? So let me paint my microclimate. A cow lives in a pen, which is inside a barn, and in that pen, she lies in a stall. So we have many, many, many little kind of microclimates around that. And within that, we also know that we have air hits a solid object and is going to bounce everywhere. So this is why we have to have this absolute focus on what is the requirement. They adopt good strategies right throughout their farm. So it's not just looking at the lactating cows in the barn. It's looking at all the other parts of their dairy farm and understanding the relationship and the different requirements over the fan aspect and the water aspect. So, fun fact for you. Without cooling, the body temperature of a cow will increase 1.6 degrees Fahrenheit or 3 degrees Fahrenheit, 1.6 degrees Celsius or 3 degrees Fahrenheit. I apologize, I've got to do a quick conversion and maths is not my strong point. Within 20 minutes of entering the holding pen. So I have no ventilation, no cooling. I've got all these cows packed in my holding yard. They're creating a lot of heat, and so we are now heating up our cows. And that 20 minutes of heat build up, or 40 minutes of heat build up, based on how long the cows are in the holding yard, it's going to take you 4 hours to remove that 1.6 degrees or 3 degrees Fahrenheit off her system, right? So we need to make sure that we understand what are the implications if we don't do it, or what is going to be the positives if we put the right system in place. These guys are making sure that when they do install something, they're setting it up correctly. And some of this is going to sound a little bit silly, but it really does happen. So we're putting the right fans in the right place to do the job that they're designed to do, and we're spacing these correctly based on the target airspeeds that we want to be achieving, based on the group of animals that we're ventilating and the climate that we're in and the sort of barn that we're building. We're also making sure that we have enough electricity. Funnily enough, that becomes a bit of an oversight, and I've been on places where we've supplied the equipment, but they can't run at 100% because we actually don't have enough electricity. With regards to soaking, another trap is not getting the correct water pipe size coming to the soaking. These guys will make sure that the farm water supply is going to be correct flow rates. I've got the right size pipe going down my feed lane. I've spaced my nozzles correctly. I've got the right water flow, and I have the right water pressure. So, and they are making sure that everything is well maintained and it's fully operational. Because yeah, it's great having a fan in your barn, but if the fan's not running, it's actually not doing anything. So to me, the good or the gold are the people who are wholly invested in that entire process. Group number 2, our silver standard. So these guys, in my opinion, are using half of the tools, right? And so what does that look like? Well, you know, and I've thought through this. It's the producer, they know most of what is needed. However, they believe that they can't afford it, or they're confused, you know, and that confusion is trying to figure out what is the best system for their location, their farm, their herd, or they believe that the system that they have in place is what is absolutely required to get maximum productivity from their herd. Or they have a friend who has this system and it works well for them. However, where does that friend live? Is the climate the same as where my dairy farm is? Or the facility is an older one. So it means that, you know, they've installed older fans, and these fans and the cooling actually does need upgrading because it's not meeting the demands of the modern cow. And as we know, the modern cow, she's got bigger. We're actually getting them to produce more. So as they're producing more, they're eating more. And as a result, these guys actually do go into heat stress a lot sooner. So I'm really not sure how in tune they are with their farm, or how old that information is that they're using to determine their ventilation strategy. Now, the reason why I say that is because there is so much information available on the internet, but there's a lot of very old information out there. And, you know, one of the pieces of old information that you still can access quite readily on the internet is around fan spacing. So the rule of thumb was the fan should be spaced every 10 fan diameters apart and should be angled down at the cow. So yep, I agree, it should be angled down on the cow. However, that 10 fan diameters no longer applies. Part of that reason is that, you know, we have fans which are 36, 55, 72 inches in diameter, but you see so many different motor sizes. I've been on farms where you have a 72-inch fan, but it's only got a 1.5 horsepower motor. That fan spaced every 10 fan diameters is not going to achieve the required airspeed that I would need on my dairy farm. And I've seen that a lot. I've been in a number of dairy farms in a number of different countries where they've got these 72-inch fans, these little motors, and on the fan side, so here's the cow, so on the fan side of the cow, she is absolutely covered in flies, right? So the farmer believes that they have an effective solution. Part of that is that the fan didn't cost very much, but at the end of the day, they are paying for it in terms of the operational costs, because you still have to pay for electricity, but they're losing productivity. So they're paying for it in the fact they're not getting the same amount of milk, they're not getting the cows and calf, they've got a whole lot of other animal health issues. So fan selection, they possibly don't understand how air behaves, how motor size impacts on the speed in which the air moves. They certainly don't understand if I have an obstruction in the way the air is going to hit it and bounce over or bounce around, and it's not going to come back down onto the cow. So they perhaps don't necessarily have the right advice, or they're choosing, due to cost or other reasons, to not implement a solution 100%. They aren't always using the best strategies farm-wide. So, you know, here's an example here of a whole lot of little fans. And in this scenario here, perhaps they don't understand the additional stresses that go on in a parlor or in the holding yard when I've got all my cows packed in together. And, you know, they're believing that these little fans are going to do the job. They don't understand the importance of airspeed, particularly when I am closely stocking animals, right? So not getting the handle on fan performance, not getting spacing right, they're either too far apart or they're too high, or they're using something which is easy, more commonly available. Okay, so again, I believe that these guys aren't understanding the true impacts of heat stress if they get it wrong, or they've put something in and it's been better than nothing. So they've seen an improvement. They're going, yep, I've got that right. So, you know, again, let's look at good or good enough. Understanding if I do something, what is the implication? So here you've got these cows there standing side on to the soaking. So I've put soaking on my feed lane. Yep, I've got that right. But what I've done here is I've created a cooler environment for the cows. So clearly these cows have figured out that if I stand sideways on this, I'm going to be, you know, it's the most effective cooling for me. It's a lot nicer if I stand here. And so after I've eaten, I'll just stay here and I'll stay cool, versus I'm going to go, am I really going to go lie down in those free stalls over there? Those free stalls, they haven't got fans, or they have fans and they're not working, or they have fans and they're just not working properly. So these cows are going under the soakers. This is the most comfortable place. This is where I have created a micro environment in the wrong location. So, you know, when you walk through a barn, it's really important to have a good look, right? We walk through this barn, and when you walk through across the top of it and you go, oh, okay, well, these cows are all standing there. They must have either just delivered feed or they've just pushed up the feed. But if you really go in and you really have a look at what's going on, you could clearly see that these guys had all eaten. In fact, no cow had their head down. They were all standing, their heads through, their headlocks, and their sole purpose in life right now was to just be cool. So it's important to understand, when I put a system in place, what impact is that going to do, or what impact is that going to have on my cow behavior? Do I really want my cows to be standing there at the feed lane, or do I want them to lie down? So how do I make them lie down? Last group, bronze. Okay, these guys don't understand the impacts on their business. Maybe they think it's not necessary, or as I mentioned before, maybe they just don't think it's hot enough. I really don't think that these guys are really in tune with their businesses. They don't understand when a cow goes into heat stress, what happens, or they've been misinformed. The jury's still out on that. They definitely see ventilation as a commodity. So it's a cost to the business. It's not an investment. They're not believing that if they put in the fans and they put in the cooling, that they're actually going to get some payback, right? So they absolutely know that heat stress is a problem. But it's the old adage, right? Well, herd performance always drops at this time of the year. It's something that they're going to accept. I was in a country where you catch on fire in the summer, and they had nothing, no ventilation, no cooling. And interestingly enough, through the summer and a little bit past summer, they had between 0 and 5% conception rate. And their daily milk production, it dropped down to the low double digits. In an environment like that where you're milking cows and you're instantly seeing your milk production drop down and you're seeing your reproduction drop down, how is it that you can't figure out that disconnect? They also don't necessarily understand, or they absolutely don't understand, what heat stress does to cow behavior, right? So one of the biggest impacts of heat stress is lameness. When it's hot, the cows, they do lie down, but they heat up super, super fast. So they stand up to try and cool themselves down. So heat stress cows will have a lot longer standing up times. Classic quote that I hear, either in hot climates or at hot times of the year, is, I don't understand why my lameness is so high. There's a whole lot of research out there again. And I pulled out a piece from a paper from Dr. Jose Santos of the University of Florida, who had a similar comment. So it's not uncommon to observe high incidences of feet problems subsequent to a hot summer. So dairy farmers routinely complaining about the increase in lameness through the months of August, September, and October. And what happens? We see this. The cow resorts to other methods to try and cool herself down. So you see a lot of cows standing up. You'll see a lot of cows kind of standing at the fresh air end of the barn, where you've got the prevailing wind coming in, or in extreme cases, you've got cows in there kind of trying to cool their feet down. Like it or not, consumers are demanding happier cows, healthier cows. They want transparency. They want cow welfare to be important. And as producers, we have to be striving for the same thing. And the reason why I say that is because if we strive for the same thing, we are actually going to see more profitability, right? We're going to see more milk. We're going to see more cows in calf. We're going to see less animal health costs. We're going to see less involuntary culls. And again, there's so much research and there's so much data out there which demonstrates how and when we design a good system, you actually do get good results. So why aren't we why aren't we all getting it right? Why is there a disconnect? We all have the same tools available. This is a really good one. THI, for example, helps us to understand when cows go into heat stress. And we all know that 68 THI is when we see mild heat stress. So what does 68 THI look like? Well, it looks like 22 degrees Celsius or 72 degrees Fahrenheit with a relative humidity of 45%, right up to 65.5 degrees Celsius to 80 degrees Fahrenheit and a 0% relative humidity. So it's not a very hot temperature with a moderate humidity. So the summertime, it doesn't matter where you are, unless you're in Antarctica or possibly Greenland, your cows will experience a level of heat stress. We know that cows lying down, they accumulate heat quickly. So for every hour they lie down, they are going to increase their body temperature by 0.5 degree Celsius or 1 degree Fahrenheit. And it will take them twice as long to remove that heat. So when they stand up, they remove 0.25 degrees Celsius or 0.5 degree Fahrenheit per hour. So if we don't get it right, for every hour of lying down that they heat up, they've got to spend 2 hours to try and cool themselves down, right? So thing to remember is that temperature increases the number of, doesn't increase the number of standing up times, it actually increases the duration. So what you find is that our cows still may lie down for, I don't know, 10 times a day, 6 times a day, but she doesn't lie down for as long. And so what you do see is cows may only be lying down for 6 hours per day to just cool themselves if we haven't got it right. And we see these guys, they're standing up and they're panting. And what's the rule of thumb? We need our cows to be lying down for at least 12 hours per day. And as again, to point out or to reiterate, if we have heat stress, we see a drop in milk production, we see our components change, we see our conception rates drop, and our milk production and our conception rates, they will stay low if we have a long heat stress period and or we are later days in milk. So you might see the hangover effect from heat stress 4 to 6 months after the event. We also see when a cow is hot, she doesn't eat so much, so it means that her rumination rate drops, and then we start to see a whole host of animal health problems. So mastitis we know, lameness we know, but we don't see it until it's too late, but you end up with issues with cows getting acidosis and cows getting ketosis, right? We don't really need our cows to go on a keto diet. So again, to reiterate, we know that ventilation rates are critical and they impact on cow productivity. Air movement over the stalls helps our cows to lose heat and keep our cows lying down for longer. So we're going to look at a study which I found from a Nigel Cook webinar, where it looks at the heat stress and resting behavior relationship. So you can see here on the left hand side we have the THI, and on the right hand side we have the lying down times. So in this particular study, it looked at what happens to the lying down times for cows over a 6-day period. And in this little trial, there were 30 cows. It was a freestall barn, and as you can see, each day the temperature got hotter. So we had a THI of 67, and it went up to around 79 THI. And as every day got hotter, you can see that our lying down times were less. So we went from 10 hours a day of cows lying down, which still we've kind of missed the mark on that one, but it dropped at an 80 or a 79 THI, it dropped down to only 6 hours per day. So we lost over 6 days, 4 hours of lying down time. And we all know that if a cow lies down for longer, so the longer we can get our cow to lie down in her lying down period, the more milk we make, because we can push, or the cow pushes a lot more blood through her udder. So fan selection has the highest impact on our operation, right? If I get it right and I can get my cows lying down, then I'm getting a positive result from our fans. But we also have to remember, you know, we have that capital cost for our fans, but we also have the operating cost. And every single ventilation has that operating cost. There are a lot of variances out there in fan performance, and so it's really important that we look at as many fans as possible to make sure that we are selecting the right sort of fans. So the catch though is, and this is where our silver and bronze people kind of get tripped up, is that the more efficient fans tend to be the more expensive fans. So, but having said that, our payback is that our operating costs are lower. So if I have a fan that is more efficient at power conversion, then I'm actually going to save money in electricity versus a fan that is not so good with electricity. So my power bill ends up being the same if I've got a high efficiency fan or a low efficiency fan. So you end up paying for it. So selecting the fan, as I said, is really important. And you can actually check the fan's efficiency rating, and that efficiency rating is CFM per watt. And so this is the information that we want to be looking for from each of our fan manufacturers, so that we can make sure that we are getting the best bang for our buck. However, one thing I want you to remember is you have to compare like for like. So you have to look at a 72-inch fan with a 3 horsepower motor and compare that to a 72-inch fan with a 3 horsepower motor. You can't look at a 72-inch fan with a 3 horsepower motor and a 1.5 horsepower motor, because you are going to get differences. So like for like is super important. Water, okay? There was a study done back in the 40s that actually found adding water with air, so a combination of supplementary air, did actually have an impact on the rate of which the cow's body temperature and respiration rates dropped. Okay, they found that fans and water was more superior to just using fans or just using soaking. So here is a study that was done by Burke, Smith and Hana, and what it looks at was the impact of fans or fans and soaking. So this in this study, the temperature was 36 degrees. Thank you, Gordy Jones, for that at your previous in your previous webinar. And doing nothing, you can see nothing changes, right? On the left-hand side, we have the respiration rates, and you can see that through that whole period, the respiration rate stayed at about 100 breaths per minute over the 90-minute period. When I add fans, nothing much changed. You can see here that it was just under 100 breaths per minute, and it dropped down to about 90 breaths per minute. If I just soak my cows, you can see that I got a significant change in respiration rates over that 90-minute period, but still I'm only achieving, I've only dropped it down to 80 breaths per minute. But the cool thing is that soaking every 15 minutes and adding fans, I actually did make quite good inroads. I went from 100 breaths per minute down to 70. Again, when I just soaked for 10 minutes, you can see that soaking for 10 minutes gave me the same outcome as soaking for 15 minutes. And when I added fans to my soaking, I got my breath rates down to 60 breaths per minute. When I add just soaking at every 5 minutes, I get the same result as fans and soaking every 10 minutes. My biggest impact was when I was soaking every 5 minutes with fans. So after 90 minutes, I pretty much got my cows down to normal respiratory rates. And this is where we're at a barn of 36 degrees Celsius. So we know that wetting frequency and the level of supplementary airflow does actually have a dramatic impact. And we saw in this study here that we got the best or the fastest result when we soaked our cows every 5 minutes at that ambient temperature. Our respirations dropped the fastest. So what it's saying is that fans alone is not going to have that significant impact on reducing our body temperature. If we add soaking and we get our wetting frequency correct, we actually do manage to get our cows back down to almost normal in terms of heat stress. So soaking, it too is also our best and most effective way of cooling, because we are addressing the heat directly on the cows. So we're putting water on her back, and then the air is blowing onto her body, and we're evaporating the water off, and we're pulling the heat off the cow's body. And this is why we get such a great result when we set it up right and we get our soaking frequency correct based on the climate. The other option in terms of cooling is what's known as indirect cooling or high pressure fogging. There's not a heck of a lot of research out there, and I have looked and looked and looked, and I really can't find very much. What we do know is that high pressure fogging cools the air around the cow. So it's creating that temperature difference between the cow and the environment. And so that rate of heat transfer from the cow to the environment is actually better. Plus, she's actually breathing in cooler air. The thing that we have to be very mindful of is two things. One, airspeed is super, super important. So we need that air to be pushing through the barn because we want to push the cool air through, and we also want to take out the hot air that we've created as we're transferring the heat into those little microns of water. And also droplet size is super, super important. So we want small droplets. So around, well, the industry says 2 to 60 microns, but you want to go to the smaller size, because the reason why we want to do that is that we want to have more water surface contact with the air. So the finer the droplet, the better ability we have to cool the air. And the other advantage of the finer droplet is it means that nothing gets wet. So bigger droplets means that we run the risk of actually making the bedding or the free stall wet. And we know that if we have wet bedding, then we're going to end up with mastitis and other problems. So one of the tricky things is, though, that high pressure fogging is a lot more, a lot easier to manage when it's in a dry climate, because it means we're not struggling with the humidity, because we know when we add moisture like this, we're upping the humidity in our barn. So heat stress is a global problem, and the Chinese government have actually come out and said that it's the #1 issue or impediment to feeding their country. The severity of heat stress is significantly different based on the climate. Production losses on farms without cooling were cited by Wisconsin University as ranging from 183 kilos or 400 pounds per cow per year in climates like Wisconsin, so not excessively hot, have distinct climates or has a short period of hot or heat, to the excessively horrible climates as in Florida, where farms are losing about 1,800 kilos or 400 pounds per cow per year. So producers need to know when do their cows begin to experience heat stress and what do we need to initiate the cooling mechanisms. So Karen, I believe that it's poll time. So my poll is, when do you need to turn on the fans and or the cooling? Is it peak daily heat? Is it average daily heat? Is it minimum daily THI? So what is the most indicative of heat stress? So I'll give you guys a few minutes to do that. And while you're doing that, I shall continue on because I am mindful of the time. No, I won't, because I can't progress. How long shall we give them, Karen?
At this point in time, we've got 10 people who say minimum daily THI, and we have 5 that are saying average daily THI. Oh, and we've got a couple here that are saying peak daily heat. So most people believe it's minimum daily THI.
Okay, so those people there that have said minimum daily THI are bang on. We want to be turning on our ventilation when we start experiencing mild heat stress, and then we are bringing in the water when we get to that to the certain threshold. So to conclude, when we have a better understanding, we can make better business decisions. So that better understanding is the importance of the role fans and water plays. The available information unmistakably shows that heat stress hugely impacts on cow performance. And the results are huge in terms of the economic losses to you as a dairyman and to the dairy industry. I mean, in 30 years' time, there's far more people in the globe that are going to be needing to be fed, and dairy is one of the key components to feeding the world. So physically cooling cows has the greatest impact on feed intakes and milk production. It's greater than anything else that you could do on your dairy farm. And by that, I mean things like modifying your feeding program. Okay, your results or your outcome of modifying your feeding program is not going to be nearly as significant as getting the ventilation and the cooling right. So a combination of fans, so the fans is to increase convection heat loss, so I'm blowing it off here, and either soakers or fogging, depending on where you are, to actually promote the evaporative cooling is the most effective way to cool cows. So fast moving air helps carry the heat away from the body, and we're going to increase the evaporation rate through soaking. So point to note is target air speeds are climate specific. So right now we're kind of sitting around that 2.5 to 3.5 meters per second, or 500 to 600 feet per minute. All right. Fans in the resting area, not negotiable, because we want these guys to be lying down for 12 to 14 hours. And we want the air to move where the cows are resting, so that we are creating that cool, comfortable microenvironment right there where they're lying down. We also do want them to eat. And these guys are going to eat between 5 to 6 hours a day. So we also need to make that area a priority as well. And we're cooling cows through water or through fogging. Holding yards, absolutely paramount. Okay, that's where we actually make these cows super, super hot. They're hot because they've walked to the parlor. They're now going to be really hot because we've scrunched them all together, and then they're hot walking back. And so we actually have to make sure we don't elevate their heat stress whilst they're being milked. When we choose the right system, we're actually going to get a return on investment, right? As I said to you before, the variation is in the efficiency of the motor, and we actually end up paying the same or similar operational costs if we get a cheap fan, which is really inefficient with converting electricity to air, versus a slightly more expensive motor, which is going to be better at converting electricity to air. And so you're getting an easy payback in terms of the operational costs over time. Fun fact for you, just before I close off, is that we were on a dairy farm working with a customer. Their first 1,000 cow cross vent barn, really not the right barn to be building in their environment. Very hot, very humid conditions in the summer, and really not that cold over winter. They had baffles. They had a huge variation in airspeed under the baffle, so anywhere between 0.5 to 2 meters per second, or 98 to 450 feet per minute. In the summer, pregnancy rates dropped. They dropped down to 10%, and they lost 11 kilos or 24 pounds of milk per cow per day. Second cross vent barn, we had the pleasure to help them put a strategy together. So we worked on a combination of baffles and circulation fans. We targeted our airspeed over the free stalls to be more like 3 to 4 meters per second, so 600 to 700 feet per minute. And that's when all the fans were running at 100%. And so our results in the first summer was our pregnancy rates held at 27%, and our milk production over the total herd dropped by 4.5 kilos or 10 pounds per cow per day. Thing to understand was last year was the first year, and he was still moving cows between the barns. So cows that were in the first barn, as he was seeing the results, he's moving them into the second barn. So this summer we'll be looking at what's going to be the difference between the old barn and the new barn. So in closing, we all know that better systems put in place will mitigate heat stress. It'll improve cow welfare, and it will improve cow productivity. Our business has to become more sustainable, and by that I mean also more profitable. Okay, more profitability is more milk, reduced calving intervals, so I'm going to get more fresh cows in my herd, and that's instantly going to give me more milk as well, and I'm also going to have healthier cows. If your ventilation and your cooling system provides the correct air speeds over the cows, we're getting fresh air throughout the year, then it's always going to be a sound investment. And at the end of the day, we want to have a business with the highest efficiencies and consistent profitability. And we all know how volatile our industry is, that our milk price goes jiggity jag. And so when we're at a low point in milk price, we want to make sure that we remain above the red line. So again, thank you very much for joining me today. And we open the floor up for questions.
Excellent. So our first question is, would you consider using soaking in central Canada and in Ontario? Would there still be a payback?
There's a big version of me now. I always look at your climate data before I make any recommendations. I do know that you guys do get quite hot summers, so I would absolutely make the statement that yes, you would see a return on that investment. all you need to do is go look and see what's going on with your milk production through the summer right now and your reproduction, to figure out, based on literature and scientific papers around your expectation of increased milk production and reproduction, to understand that yes, there is a return.
Perfect. And our last question, since most dairies strive for excellence and consistency, why do you think new dairies compromise on ventilation and cooling in the barns and holding areas?
So, so are we able to get an understanding of what we mean by new dairies? So a new dairy farm, if it's an experienced herdsman, is not going to make those sorts of mistakes, I would like to hope. When we talk about new dairies as in new dairy farming regions, we see those mistakes made because, as I was saying, they just see it as a cost, right? Oh, I can't afford to do that. Even though, you know, we know that when we build a new dairy farm, the break even is between 30 and 32 kilos of milk per cow per day. So somebody might have to convert that to me into pounds. I apologize. So if we want to be profitable and we want to be moving forward in our business, then we have to use the tools to make that work. And it's that misinformation or the reinvention in countries where English may not be the first language, so it's not always that easy to go do searches on the internet. I mean, I know from personal experience with my guys in China, the who could speak English, they would go and do research on the internet, and they would be able to read all the research papers outside of China. All the guys that couldn't speak English, they could only rely on what was available within their country. So I think we also have that sort of challenge in front of us in some of these new regions as well.
Perfect. We had another question come in, and I will ask it of Sue, and while you're answering, I'll launch the poll about how we did, and if people could fill that out, that would be great. So in a barn with fans, how do you deal with the air example, or deal with the air example barn roof opening?
How do I deal with the air?
It says deal with the air example barn roof opening. So
in terms of how wide or how big my open ridge is, I'm assuming that is what we're asking. So that hot air rises. So our fans are designed to push air down onto the cows, and we will push some of it out. In a natural vent barn, some of it's going to go out the sides, and we need the rest of it to go out the roof. So the size of the ridge, the open ridge, is always going to be based on the width of the building, and also the pitch of the roof plays a part on how big that open ridge needs to be. So it's very barn specific, I'm afraid, but they are the things that you have to take into consideration. But the misconception is, if I've got great air flowing out of my open ridge, that's perfect, but that's not providing me with ventilation and airspeed down over the cow. All it's saying is I'm doing a great job of removing the nasty, hot, humid air full of ammonia, carbon monoxide, blah, 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 and it's all escaping out correctly, and it's not building up. Because the other thing to understand with ventilation, when you go into a barn and there's no ventilation, the steel actually starts to break down, or the galvanization gets eaten a lot quicker because of all the toxic, noxious gases like ammonia and carbon monoxide and carbon dioxide. So again, you're preserving your facilities by pushing air. And again, if you don't get your ridge right, you're going to end up with this yucky air still trapped up in there, and then you start to see your roof rusting or your structures rusting.
So in addition to that question, they've come back and said, so 22 degrees is the optimum temperature?
For turning fans on, or?
I believe so.
Again, yep, we would turn them on a little bit earlier, but yeah, you would probably turn them on around 20-21 degrees would be the recommendation. Some guys will turn them on when they get to that minimum THI, which is 21, 22. Yes.
Perfect. And then John Moran, you had a question. Would you like to ask it yourself?
Can you hear me?
Yes, I can.
Good, okay. We're starting from scratch. Nothing's been built and we've got a location. Can you tell me what information would just temperature, humidity index? What else should I collect from that area prior to designing any facilities?
Okay, so your temperatures, so maximum, minimum, average, the humidity is important to be taken into consideration. Rainfall data can be also an important factor as well. And that they would probably be the critical ones around the temperature information that you would be wanting to gather.
So you're saying maximum humidity or sort of typical humidity at midday?
Well, so what happens with humidity is as your temperature goes up, your humidity goes down. So yep. As your temperature goes down, your humidity goes up. But if you normally get a good idea when you look at your average humidity, because if your average humidity stays below 50 or sits between 50 and 60, then you're not at in a high humidity location. But if your average humidity is kind of 70, 80, then you know that from a cooling strategy anyway, you really only have one pathway, and that is with the direct application of soaking. So, but it's always good if you can I always love to be able to look at maximum and minimum relative humidity through the day, because then it allows you to figure out at night when the temperature drops what is really happening with my humidity.
Okay, now in a second site in another country at 1,600 meters above sea level.
Yep.
Then is it 25 degrees centigrade is sort of the critical temperature if
just because you're up high doesn't mean that you aren't going to suffer from heat stress, because even at a high humidity, a high elevation, you're still going to suffer from humidity. So that's why it's really important to get all that data.
Yep.
And if you're able to get wind speeds, because you have to remember Mother Nature doesn't blow at 3 meters per second, 24 hours a day, 7 days a week.
Yep. Yep.
And when you're in a tropical region, you need those fans running all day, every day. That's sure. One of those things you just can't escape, unfortunately. Yep. So even working with customers that are high up in altitude, they're building tunnel ventilation. Not negotiable for them.
Thanks very much for that, Sue.
My pleasure.
Well, thank you everybody for coming out. As you can see by the picture on the screen, we have our next webinar on July 24th. Nigel Cook will be coming to speak with us about adult cow ventilation, and we look forward to having you there as well. So thank you, Sue, for this. This was great, and I hope everyone has a great day.
Thank you very much, and feel free to drop me a line or drop a line through to Artex if you have any further questions.
Thank you.
All right.